Okay, so we are working on graphing exponential parent functions. And if you are doing this via video, you need to fill all this in by yourself and come back and check this. The x's were given, -2 to 3 is what I told you to use for the x's, and plug that in and find your own y's, and then plot the points. Pause the video and get that done, and then restart for a discussion. Let's discuss these. Just compare the one on the left to one on the right. Use some words about the graph. What's it? What can we say? What happened? Okay. Use the word reflect. Over what? Did it reflect over the y-axis? Everybody stay in on this conversation. Did this flip over the y-axis? In other words, did this point come over here? And this point come over here? And this over here? And all of this over there? Yes? That's what happened? Okay. Now, we haven't had anything this year reflect over the y-axis. We have had some things reflect over the x-axis. For instance, if we have a parabola going upward, that's the parent function. What happens to the parent function when it flips over or reflects over the x-axis? What change would it be? Y equals what? Negative x squared. In other words, the a value, which this doesn't really have an a value, it's 1, changed to negative. Make sure you're listening. This is where you learn. So now this is an a value change. It took the whole equation and changed it to negative, and it reflected it over. This one's a little bit different. This is reflecting over the y-axis instead of the x-axis. From yesterday's lesson, what could this be written as a negative exponent instead of a positive exponent? If I make this negative, equals what to the power of negative x? If I change the exponent to negative, what does it do to the 1/2? Flips it. And so 1/2 reciprocated is a 2. These are equal. Agreed? They're equal. Now, think this through. If I took this equation and put a negative in front of it right here, it would have reflected over the x-axis. You with me? But because the negative is really on the x, it reflects over the y-axis. You see it? Now, you'll do a lot more of this in pre-calc. It's called a b-value. It's called a b-value. And we don't really use much of a b-value in Algebra 2. We use a lot of b-values in pre-calc. So, but I just want to show you, and we're really not going to write it with the negative exponent. We're going to write it with the fractional base. This is called your base. Right here is your base. This is your exponent. So we'll write it with a fractional base most of the time. I just wanted to show you how that worked. It's a negative on the x. It actually reflects over the y-axis instead of reflecting over the x-axis. Okay, so now, does this stop right here? Is that a stopping point right here? Did that stop? For video land, I got to point to it. Is that really a stopping point? No. What would keep happening? I would have needed to do like a negative 3. No, on this one, I'm sorry, it's not that. If I had put a 4 here, it would be 1 what? 1/16, right? And which is going to get even closer. So what do we call the x-axis in this case? So this is, everybody dash your asymptote in there. Dash your asymptote in there. That is an asymptote. Let's get rid of this green over here. Where's the asymptote on this one? Same one, right? Do we have a vertical asymptote on an exponential? No vertical asymptote. Okay, let's scroll down. Did everybody get this on? You see in the same asymptote? Dash in all the asymptotes. Do you agree that the 1/3 is a reflection over the y-axis of the one with the base of 3? Yes, Ms. Fillers, we do. Okay. Now, what do I need to do with this graph that the 4 to the power of x? Always extend on and show that you realize it's going to go on forever. You know what? One thing I don't have on this, which we need to write. Everybody tell me the domain and range, and are they the same for every graph? Let's look at the domain. Look at the domain for every graph. Negative what? To infinity for all of them? Which one does not have a domain of negative infinity to infinity? Is it going forever left and forever right? Kind of slowly, but it is going. Remember, we said there's no asymptote. There's no stopping. It's going to go slowly, okay, to the right and fast up. This one's going from negative infinity to positive infinity. So the domain for all of them is negative infinity to infinity. What about the range for all of them? 0. Did I need a parenthesis or a bracket right here in front of the 0? Parenthesis because it's not touching, okay? Not touching. Okay, excellent. Pretty easy, right? Let's see how to make some transformations on these. Now, before I do that, I need you to find one point that was consistent with every graph. One single point that was consistent on every graph. Do you have it? Don't say it. Everybody got it? What was it? 0, 1 in every graph. Now, we're going to put what we call a ghost point. And the ghost point is actually going to be right below, on your, and you don't need it for now, but know that your ghost point would be where your axis kind of cross, where your new origin. We're going to call it a ghost point, meaning it's not there, but it's a takeoff point for us. If it were a parabola, it would be where our vertex was. If it was a rational, it would be where we called, remember, our new origin. We'd find our new origin. Okay, we're going to put a ghost point there this time. I'll show you how that works. Okay, everybody flip over to the back. So now what we're going to do is transform these. Have you noticed every single unit we do, we learn a new function. Quadratic, we learn how to graph it. We learn how to move it around, transform it. Then we learned square roots. We learned what the parent function looked like, and then we move it around. Then we went to rationals. We learned the parent function, we move it around. Here we are in exponential. We learn the parent functions, and we're going to move them around. It's real easy. In 10 minutes, you're going to be experts. Ready? Maybe even 5. Okay. So, do you notice the base here? That 2 is a base. Okay? That means you need to use the parent function with base 2. Okay? So, everybody write yourself a note. Use parent function table with base 2. Okay? So you're going to, the front of that you just filled out, you're going to need that over and over and over again because you're going to need those tables to see your base, your bases. Okay, here we go. So let's go ahead and fill in our table for the parent function y equals 2 to the power of x. You can just copy it. Let's see, -2, -1, 0, 1, 2. We don't need the 3. That's a little too far. Okay, what is 2 to the power of -2? Need to get good at this. 2 to the power of -2. 1/4. Remember, you have to flip it over. 1/4, then what? A half, 1, 2, 4. Okay. That would be where we would graph this if we weren't moving it around. But we are moving it around. In fact, the easiest part is what's happening to our vertical asymptote? Exactly. Up 4. Let's everybody go to it. Up 4. 1. Dash it across right there. Now, what's happening horizontally? We don't have an asymptote, but we have that ghost point. Where are we going to move it to? Look right there. Careful. That's kind of the inside, or the side to side always lies. 3 to right. 3 to the right. So everybody go on your asymptote. 3 to the right. 1, 2, 3. And put a ghost point right there. I'm going to change colors. 1, 2. I call it a ghost point. That's your kind of your new origin. You with me? Your new origin. Now, this one's kind of good because it doesn't have a stretch on it. Remember how we stretch things? No stretch here. The stretch would be right here in front. See right there? No stretch. And which means no A value. This one doesn't have an A value. So from here, you ready? I'm going to graph it in blue. Everybody get at your ghost point. Go 2 to the left and up a 4th. 2 to the left, up a 4th. 1 to the left, up what? 0 to the left, up 1. 1, 2, 2, 4. Draw it in and you're done. Can't get much easier than that, can it? Okay. Questions, comments, or concerns for that? Good question. Let's go to example 2, and we got a stretch for you. Okay? You know what? I don't like example 2. Let's change it. What? It's not too bad. Let's change it. Let's change it. Let's put a 3. No, let's leave it at 2. Sorry. Y equals 2. Let's put a 1/3 x to the power x minus, let's put plus 2, and then plus 3. Let's do minus 3. Minus 3, sorry. Minus 3. What? You don't need it in the parentheses. I'm not sure why it was on the original. It doesn't really matter. Okay, this is the same as this. It would have been okay that way, but really, this is better. Okay, better. That may have been a typo. Okay, here we go. Everybody get your vertical asymptote and your ghost point by yourself. Vertical asymptote, ghost point. Check with me when you're done. Okay, now that you have that, any questions on that? No questions? Now that you have that, let's fill in our table. Always -2, -1, 0, 1, 2. What is our parent function for this? Y equals, what's your base? 1/3. This is your base right here. So if you need to, flip back over to the parent function for 1/3, but I bet we can think about it. Let's see. 1/3 to the power of x. So this means 1/3 to the power of -2. The negative means flip it over. The 2 means to square it. So this is 9, 3, 1, 1/3, 1/9. Pretty easy, right? Almost easier to think about them than flip it over and copy them. Okay, here we go. This one now has a stretch. The A value, which is a 2, stretches it. The Y's, remember, it stretches it vertically up. So everybody come out to your table and let's multiply by 2. Okay, and then go ahead and find the values for those. The new values would be 18, 6, 2, 2/3, 2/9. Beautiful. Now let's graph it. Here we go. So from your ghost point, we go what? 2 to the left and 18 up. 2 to the left, up 18. 1, 2, 3, 4, 10, 11, 12, 13, 14, 15, 16, 17. So it's kind of up in the question. Okay, now what? 1 to the left, up what? 6. 0 to the left or right, up 2. 1 to the right, up 2/3. 2 to the right, up 2/9, which is almost nothing. So here we go. Let's connect. This one is very steep. Very steep. Okay? Easy enough? Not bad, is it? Not bad. See, I told you, experts in no time at all. Now, do your homework. Front and back of the other worksheet is your homework.